We are going to look at this first question and how to apply our equations of motion. There were three of these equations of motion that I derived previously. Now I want to state that yes, there are sometimes a question might be given to you. One of these equations of motion will solve it directly. There are other forms of questions that might be given to you and might require that you combine two or more of these equations before you can get your result. Let us see what this GCE question is about. A body which is uniformly retarded comes to rest in 10 seconds after traveling a distance of 20 meters. Calculate its initial velocity. These are the options. We are to calculate the initial velocity of this body. But remember, according to the question, the body was uniformly retarded. And it was retarded until it came to what? Rest. At the time of coming to rest, it took this body 10 seconds to come to rest. And within the period when the body was retarded, retardation, like I stated from our previous class, is negative acceleration. It means you are reducing velocity. Are you following right? And so, this body came to rest after it had covered a distance of 20 meters within 10 seconds. So with this information given to us, let us see what we can do. If you look at the question, we were not given the negative acceleration, as in the retardation value, we were not given that. But unfortunately, the three equations of motion, if you look at each of them, they all have what? Acceleration in that formula. Which means for us to calculate the initial velocity, whichever of the three equations, any one that is going to work, we must have first of all gotten the acceleration, which in this case is going to act as our retardation, that is negative acceleration. We must have gotten it first. And of course, that was the first we need to do it here. But let's bring out the parameters, the information we know from here. According to the question, the time it took to come to rest is 10 seconds, alright? And then the distance traveled S is equal to 20 meters during the time it came to rest. Now, under this condition, we don't know the retardation. A, we don't know. Are you following right? When we get the value of that A, we are going to put negative to it, which shows that it is retarding, it's reducing. So we don't know the acceleration, which is retardation, okay? And that we are asked to find the initial velocity. U, we don't also know. So our main problem in this question is to calculate the initial velocity, but we don't know the acceleration. We must have gotten it first before we can get the initial velocity. Now, how do we obtain the value of this retardation given this condition that it took 10 seconds to come to rest and that the distance covered was 20 meters during the time? Looking at the fact that we know time, we know distance S, we don't know acceleration A. Which of the equations of motion would go? We have to think of that equation of motion that has S in it, that is distance. Now we are told that the body came to rest. If the body came to rest, it simply means that the velocity is equal to 0. It simply means that the velocity is equal to what? 0. If the body came to rest. So the equation of motion that will work in there will be second equation of motion. Using second equation of motion. Equation of motion. Now that second equation of motion is given as S equal to ut plus 1/2 at squared. Now under this condition, I will say but u, okay, the velocity u is equal to 0. The velocity u is equal to 0. That is the time during which it came to rest. That implies that in place of this, we're going to put 20 place of distance equal to 0 times the time is 10, then plus 1/2 times our acceleration we don't know, then times time, 10 squared. Working in this, 20 will now be equal to, this will give us 0 plus 10 squared is 100 times A, 100A divided by 2. If you work in this, it implies that 20 will be equal to This divides out to give us 50A. Therefore, acceleration A will be equal to 20 divided by 50. If you do that, these zeros will cancel and our acceleration will be equal to 0.4. But that 0.4 will be negative 0.4 meters per square second. The negative shows retardation. Let me indicate it. Negative shows retardation. Retardation. I already explained this from our previous class. Now that we've known the acceleration, we can now use the acceleration to determine the initial velocity. And how do we get the initial velocity? Remember, we know time now. We know the acceleration, which is retardation in this case. Now, for the body to be retarded, meaning you are reducing the velocity. Something is already in motion. You now started reducing the velocity. What is the condition? The condition is that the final velocity will be equal to 0. Think of this. I started moving. As I am moving, I will attain a final velocity, a last velocity, before my motion will start reducing. That last velocity is my final velocity. Now when the motion starts reducing, I have changed the concept of my motion because I'm now reducing. The highest velocity I got to before reducing will be my final velocity. When I start reducing, that will now be my initial velocity of movement because I'm coming to rest. My rest position will now still be velocity equal to 0. What idea am I passing on here? The motion of this body that took you to a highest point before it started coming down. At that highest point, the condition of motion is that final velocity is equal to 0. So I will write before retardation, that is just before retardation, final velocity v is equal to 0. It means we know the final velocity at that case now, just before retarding, just before reducing its motion. Now that we know final velocity, and we are now asked to get initial velocity. So during retardation, initial velocity we don't know. Now we don't know initial velocity, we know final velocity, we know time, and we know our retardation. We can now use the first equation of motion to solve our problem. Using the first equation of motion. Using the first equation of motion. We can also use the third equation of motion here to get the same answer. Take note. Because we know the distance s. And in the third equation of motion, we have distance, we have acceleration, we have initial and final velocity. And we know all of those quantities apart from initial velocity, we can calculate it. But I want to use my first equation of motion because again, in the first equation of motion, I know time. There is time there, acceleration, and I know that which is our retardation here. Then initial and final velocity is also there. These values, I have them. What I'm looking for is u. It implies that v is equal to u plus at. And then our v is equal to 0. Then u we don't know. Plus our acceleration is a negative value. Minus 0.4 times time. Time is 10 seconds. If I work this out, I'll get 0 to be equal to u minus 0.4 times 10 will give me 4. Alright, to give me 4. So what do? I'll make u subject of the formula. Therefore, u, which is my initial velocity, will now be equal to 4 meter per second. And that is my answer. That is my answer. You see, from here, it implies that u is equal to this minus 4 will cross over, and that will give me plus 4. Therefore, the initial velocity of this body is 4 meter per second. Let's go to our option and see what the correct answer is. The correct answer is C. So I will take that, option C. Get set for yet another question. we've been given this question on the board, and it is required that we calculate velocity in meter per second and in kilometer per hour. Let's read through the question and see the information we can gather from the question. A bus traveling at 60 km per hour accelerates uniformly at 5 meters per square second. Calculate its velocity after 2 minutes in r, meter per second, II, kilometer per hour. How do we solve this problem? Let us bring out the information we have as given in the question. First, we're told that the bus is traveling at 60 km per hour. So it's just like I am moving and at 60 km per hour. That's my initial velocity. So I'm going to write. Initial velocity u is equal to 60 km. Any other velocity you are to get, once I start moving, maybe whether I move from rest or I moved at any particular point in time, you start counting the time. Now if you ask to find my velocity at any other time, that velocity at any other time is my final velocity. The velocity with which I approached that final velocity, that velocity with which I was moving before you now requested to know my velocity at any particular time, that one is my initial velocity. Just imagine something is moving from here. So this corresponds to a particular time, let's say t initial. At this t initial, as that thing is moving, it has initial velocity. Once you want to get the velocity at any other time here, at any other time, say t final, that velocity at any other given time is your final velocity. Okay, so initial velocity was given to me in the question to be 60 kilometers per hour. I have to do a conversion here. I want to get my value first in meter per second. So I want to convert everything to SI unit because meter per second is SI unit of velocity. Therefore, I would have to convert this, and to convert it is going to be 60 times 1000. We've done a conversion like this in previous motion classes, all right? Then this is going to be meters divided by hour. 1 hour is 3600 seconds. That is 60 times 60. So let's check. 60 times 1000, we are dividing it by 3600. That gives me 16.66 something, so we can approximate. The initial velocity is 16.67 meter per second. Okay, so the acceleration was given to us, A, to be 5 meter per square second. And then we're told the time during which we are to calculate the velocity, 2 minutes. I will convert that time to seconds. 1 minute is 60 seconds, so 2 minutes will be 2 times 60 seconds, which will give us 120 seconds. So these are the information that I know from the question. Now in the first part, I'm to calculate the final velocity in meter per second. I don't know. So to do so, I am going to think of the equation of motion that will apply based on the information given to me here. Now if you look at this information, I know the initial velocity, I know the acceleration, I know the time. I guess the equation of motion that better solves this is first equation of motion. So using first equation of motion, because in that equation of motion, we have velocity, initial velocity, final velocity, acceleration, and time. And all this information are given in this question. We have to find the final velocity. So v is equal to u plus at. That would give us that the final velocity v is equal to our u is 16.67, then multiply, this added to acceleration is 5. We are multiplying that by time, and the time is 120. So this would give us that velocity is equal to 16.67 plus 5 times 120 should give us a 600. 5 times 120 is equal to 600. So working on this, our velocity will give us, if I add it up to 600, let's see what I would get. 16.67. Alright, 600 plus 16.67. This gave 616.67 meter per second. So this is my final velocity after 2 minutes. So we're going to proceed for the second part of the question. So let us look at what we get in the second part. We have to get the result in kilometers per hour. Now to get our result in kilometers per hour, we don't need to go back and start working from beginning anymore. Since we know the value in meter per second, we can do the conversion. Let me interpret the meaning of this. 616.67 meter per second will give us a converted value of, now this thing means every 1 second this bus will cover a distance of 616.67 meter per second. That is what it means. Therefore, I will convert this meter to kilo value, to kilometer, and then this per second to hour. So this is going to be equal to 616.67. To convert from meter, this m is numerator, you know. So to convert from meter to kilometer, you are going to divide by 1000. So I will divide this by 1000, and this will give it to me in kilometer. Then all over, this thing is over second, 1 second. Now that 1 second, if I'm converting it to hour, what do? It's going to be 1 divided by 3600. To convert from second to hour, you divide by 3600. That is dividing by 60 times 60. All right, so this is the conversion. This will give it to me in seconds, the denominator in seconds. So let us see what this conversion would be. Mathematically, if I work this out, it's going to be 616.67. This denominator will go up. This is mathematics. This is mathematics. You can see it for yourself now. If there is anyone here that feels that he does not need a knowledge of mathematics, you really do. Okay, so times 3600. Then divided by, this 1000 will come down to multiply this 1. So we're going to have 1000 times 1. Therefore, velocity in kilometers per hour will give us 616.67 multiplied by 3600, then divided by 1000, because 1000 times 1 will still give us 1000. And this gave me 2220.0 kilometers per hour. This is the result in kilometers per hour. And so we are done with this question. Let us see yet another question to apply this knowledge of equation of motion.